Have you ever looked up at the sky, felt the warmth of sunlight touch your skin, and wondered how a giant ball of fire, sitting 150 million kilometers away, has the power to give life to everything we know? This is the story of the Sun, the blazing heart of our solar system, a star so massive and powerful that without it, Earth would be a frozen, lifeless rock drifting in eternal darkness. And as you dive into this journey filled with cosmic secrets, ancient myths, and scientific discoveries about the Sun, make sure you subscribe for more such fascinating explorations into the universe, because the more you learn about the Sun, the more you realize it is not just a light in the sky but the very reason we exist. The Sun is a G-type main sequence star, often classified as a yellow dwarf, though in reality its true color is white. It only appears yellow from Earth because our atmosphere scatters shorter blue wavelengths, leaving behind a golden glow. It is about 4.6 billion years old, formed from a collapsing cloud of gas and dust known as the solar nebula, and it has enough nuclear fuel to last another 5 billion years before it transforms into a red giant, swallowing Mercury, Venus, and possibly Earth, before shrinking down into a white dwarf, the quiet remains of a once mighty star. The Sun makes up more than 99.8% of the total mass of the solar system, which means planets, moons, comets, and asteroids combined account for less than 0.2% of the system's weight. At its core, where temperatures reach 15 million degrees Celsius, nuclear fusion occurs. Hydrogen atoms fuse into helium, releasing enormous amounts of energy in the form of light and heat. Every second, the Sun fuses around 600 million tons of hydrogen into helium, and in the process, it loses about 4 million tons of mass, which is converted directly into energy according to Einstein's famous equation, E=mc². This is why the Sun shines so brilliantly, continuously pouring out energy into space. In fact, in just 1 second, it emits more energy than humanity has consumed in its entire history. The sunlight we see today actually began its journey tens of thousands, even hundreds of thousands, of years ago, as photons slowly bounced around inside the dense interior of the Sun before finally escaping into space, traveling at the speed of light, taking just about 8 minutes and 20 seconds to reach Earth. This, light travel time, means that when you look at the Sun, you are actually seeing it as it was 8 minutes ago, not in its present state. The Sun is not a smooth, calm sphere. It is dynamic, violent, and alive with storms. Its outermost atmosphere, called the corona, extends millions of kilometers into space and can reach temperatures hotter than the Sun's surface, an unsolved mystery that continues to puzzle scientists. The Sun's surface, or photosphere, is about 5,500 degrees Celsius and is dotted with dark patches known as sunspots, which are cooler regions caused by intense magnetic activity. These sunspots often give rise to solar flares, massive bursts of radiation, and coronal mass ejections that hurl billions of tons of charged particles into space, sometimes interfering with satellites, power grids, and radio signals on Earth. The auroras, those breathtaking green and purple lights in the polar skies, are direct gifts of the Sun's energy, as charged solar particles collide with Earth's magnetic field and atmosphere. Humanity has worshipped and feared the Sun for millennia. Ancient Egyptians revered Ra, the sun god, who sailed across the sky each day in his solar boat. The Aztecs believed the Sun required human sacrifices to keep shining. In Hindu mythology, Surya rides a chariot drawn by 7 horses, and the Greeks celebrated Helios, the god who drove the Sun's chariot. Across the heavens, science, however, has revealed that the Sun is not a deity but a star, similar to billions of others scattered across the galaxy, yet unique to us because it is our star, the one that makes Earth habitable. Without the Sun, there would be no photosynthesis, no oxygen, no food chain, no weather, no oceans in liquid form. Life as we know it simply could not exist. Its gravitational pull keeps the planets in orbit, its light drives weather systems and seasons, and its energy has been the foundation of agriculture, civilizations, and modern technology. But the Sun is not eternal. In about 5 billion years, as it exhausts its hydrogen fuel, it will expand into a red giant, becoming so vast that it may engulf the inner planets, leaving Earth charred or consumed. Later, it will shed its outer layers into a colorful planetary nebula, while its core collapses into a white dwarf, slowly cooling over billions of years. Even now, scientists monitor the Sun carefully, using observatories like NASA's Solar Dynamics Observatory and the Parker Solar Probe, which has flown closer to the Sun than any spacecraft in history, braving extreme radiation and heat to send back data. These missions help us understand solar winds, space weather, and the risks they pose to our technology-dependent civilization. The Sun also holds clues about the origins of stars and galaxies, teaching us about fusion, magnetism, and stellar life cycles. On a more human scale, the sun shapes our culture, inspiring art, literature, and even daily rhythms. Our circadian clocks are tied to sunrise and sunset, our festivals often follow solar cycles, and our mood is influenced by sunlight exposure. Solar power, harnessed through technology, has become one of the most promising renewable energy sources, offering a sustainable path for future generations. Yet, despite our growing knowledge, the sun remains mysterious. Why is its corona hotter than its surface? What drives the 11-year sunspot cycle? How do its magnetic fields twist and snap to unleash storms? These are questions still being explored. And perhaps the most humbling fact is this: the sun is just an average star, one among an estimated 100 billion in the Milky Way galaxy alone, yet to us it is everything, the fire that breathes life into a cold, dark cosmos. So the next time you step outside, feel the rays of the sun, remember that you are bathed in ancient starlight, the product of nuclear reactions deep inside a cosmic furnace, and realize just how intimately connected you are to the universe itself. And if you found this journey into the heart of the sun fascinating, don't forget to subscribe for more documentaries that unravel the mysteries of nature, science, and space, because the story of the cosmos is also the story of us, and the sun, our nearest star, is where that story begins and will one day end.